again. I'll let you go into details, explain yourself. The floor is all yours. Enjoy.
Great. Thanks. Well, welcome everyone to Deciphering Data Architectures. Quick history about me. I've been doing this I got to change this. It's now 40 years that I've been involved in IT since I was 18 years old. And the various roles I've had over the year have been, I was a developer back, I actually started in COBOL on a DEC VAX, and over the years got heavily involved into SQL Server. I first used SQL Server in '89 when it was version 1.0 on OS2, and just fell in love with SQL Server and databases in general. And when I was a developer, I was always all the projects I was on had something to do with databases. And I even had a stint where I had fantasy football websites that I ran that used SQL Server as a backend. And then over time, I became an architect. And almost 10 years ago, I joined Microsoft in mostly pre-sales, which involves me spending my days educating customers, doing knowledge transfer about architectures and about Microsoft products. And that's probably 75% of my days. Another 25% is trying to keep up with the technology. So my role is a data and AI technical specialist in there, but I can't even keep up with the data. And I try to keep a little bit with the AI and the large language models.
And get a great offer on a Honda. Named the 2023 Kelley Blue Book's KBB.com Best Value Brand. Buy online, like reserve from select dealers, or hurry into your local Honda dealer today.
Interesting.
Grill on a new deck from Par this season. Get a free McKee.
There we go. And I wrote a book on this topic, and so this deck is based on that book. I actually had this deck many years ago. I started to educate customers on why having a data warehouse, and over time, new types of architectures came out that we'll talk about today, like the data lakehouse and the data mesh. And I wanted to put all this information that I had in my head and in my blogs and in my deck into a book. And so it came out a few months ago. You can order on Amazon, but for those on the call, if you want a free copy, a PDF, just shoot me an email afterwards and I'll send that over to you. The agenda for today, we're going to just quickly talk about the relational data warehouse and the data lake. I'm going to assume people on this call know maybe a little bit about those concepts. And so I'll dive a little bit into them, and then we'll get into the four architectures: modern data warehouse, data fabric, data lakehouse, and data mesh. And I always have to say, these are my opinions. Even though I work for Microsoft, this is not official Microsoft definitions of things. This is James Serra's. So if you learn stuff today and you go back to work, please just say, I learned from James Serra, not I learned from Microsoft, because I've gotten in trouble at times because people said, oh, Microsoft said this when it was really just me. And I could be very upfront and honest with some of my opinions of things too. And so that's why I say it's my opinion, it's not Microsoft. And I know some of you out there, you've seen all this architect stuff, especially about the data mesh, and you're trying to figure it all out, and you may wind up passed out drunk in a, oh, this is actually supposed to be Denny's. So I changed it because I spoke in Poland. There we go. And they don't have a Denny's. So I found that was their local restaurant in here. So it's not going to be funny to you, but unless I change it back to Denny's. So you don't want to end up like this guy, and I'm going to try to prevent that from happening. So let's start off with relational data warehouse. And for those that are here, if you have questions, just stick them in the chat or raise your hand, and I'll be happy to answer them. But I'll take pauses during this session to answer some questions, and as well at the end. So our relational data warehouse, at a very high level, this is what it is. It's collecting data from a number of sources, could be dozens, could be hundreds of sources, into a central location, a data warehouse, where you're going to do reporting off that. The whole idea is to make better business decisions and get insights into your company by collecting all this data. A data warehouse is not an OLTP, online transactional processing application. Those are sources that are fed into a data warehouse, but a data warehouse for itself is write once, read many. It's designed for reporting. And it's going to be the single version of truth by collecting all that data, putting in that central location, and everybody reports off that, and it's a single version of truth, as opposed to sending out spreadsheets all over the place and emailing and people not knowing where they got the data from. That's what a data warehouse is in there. Now, there's many reasons to have a data warehouse, and here are just a few of them. It's a single version of truth. The idea is, instead of having reports run off the source system, that OLTP application, and causing problems with people, it could be some order entry system and they're trying to enter customer information in there, and somebody's running a report and it takes up all the compute and causes a lot of slowdowns in there. If you copy that data instead into a relational data warehouse and then do reports off them, you're reducing that stress on the production system. I was a DBA for about 12 years. I became very familiar with the kill command because I had so many times when somebody ran some malformed query, they didn't know what they were doing, and it just overwhelmed the system. A data warehouse can solve that problem. It also can be optimized for read access. And I know probably got a lot of DBAs on this call. If you're trying to optimize things and you put too many indexes on there, it may help the read, but it'll affect the write. A data warehouse doesn't have to worry about the write, so you can put all sorts of indexes on there to make it fast for reads in there. It's a great way to integrate multiple sources of data instead of just limiting yourself to one. If you're hitting an OLTP source system in there, you can design a data warehouse so you can run reports for the past history and not have to have inaccurate reports. If, say, somebody does a report by state and people move and you try to rerun a report from months ago, it could be wrong because somebody has moved since then. There's a way in a data warehouse to track changes over time. So you don't have to say, well, I have to save hard copy reports every month at the end of the month in order to go back. You don't need to do that with the data warehouse. It also makes it easier to do self-service BI, because what you'll do is take the tables and field names that could be very confusing on a source system. I've dealt with ERP systems that had table names like T116, and if you're trying to do reporting off that, you could be very confused of what's in this table and what's in these fields. So when you copy all that data over in there, you can rename those fields to get that self-service BI. So it'll make it real easy for somebody to create reports because the tables and the fields are named appropriately. If you are going against a source system and you have hundreds, if not thousands, of reports hitting those source systems, and you do an application upgrade and say some tables are deleted or renamed, all those reports are going to break. And I've had situations where, as a DBA, I had to go and change hundreds of Excel spreadsheets that were using queries against a source system that had that exact problem. Its table names were changed. So what you want to do instead is, when you copy that data to a data warehouse, those reports that go against that data warehouse, if the application changes, that would break the ETL going to the warehouse, but all those reports would still work. They'd have older data because their ETL broke, but all you got to do is fix the ETL in one spot, and then all the reports will start running again on there. So it really helps for maintenance purposes. And if you don't have a warehouse and everybody's going against source system, you have to give them access to all those source systems, which could be a security problem in there. Instead, if you have everything copied to a warehouse, you just got to give them access to the warehouse. So less points of entry, we'll say, and so therefore it helps with security. You can keep data forever in a data warehouse, usually because it's, especially in the cloud now, you have, in many cases, unlimited storage, and it's usually pretty cheap. So I can keep data forever, where in a data warehouse, a source system, you may delete data for performance reasons, for running out of space, and you don't have to worry if that data is copied to a relational data warehouse. You can go ahead and keep doing that, deleting the data, because there's a copy in a data warehouse for reporting purposes. It also allows you to do things like master data management. You can build hierarchies, and there are things that would be really difficult to do in a source system. And you'll find problems with the data as it comes over. It needs to be cleaned. And through that process, you will uncover issues with the source systems. The example I always use was I had a customer once that when we copied the data over, and one of them was the birth dates of customers, we found birth dates in the future or dates when people were 500 years old. Well, it turns out they had to enter a date, and they didn't. If they did, to continue in the application, if they didn't know it, they would just put any kind of junk in there. So that was a problem, and we were able to tell the people, like, you got to put a check in there so they have accurate birth dates in there. So it can help you, kind of a side benefit, plug holes in the source systems. And the idea is if you do all the proper things like renaming the tables and fields, you're going to have self-service BI. You can avoid having, if you're in IT, having to be asked to create reports. I really didn't enjoy that when I was a DBA, creating reports for people. So instead, spend the time up front, create a proper data warehouse, and then all the end users can go and create reports without bugging IT. Question I seen that, and there's somebody had asked this before the presentation there. Do you more commonly see Kimball or Inman architectures for relational data warehouses? Is there a preferred one of these for use in current Azure warehouse systems? So I cover a lot of, I don't do it in this talk, but in my book I cover a lot of Kimball and Inman. And what I wind up seeing is usually a hybrid of both in there. Kimball is more of start schema, data mart type of things, where Inman is more of a large data warehouse that has everything in there and is third normal form. And that was the way they were when they first came out with those books that I have back on my shelves there. Over time, they've changed and have incorporated other people's ideas. And I've talked to both of those guys for Inman for the book and previously with Kimball, and Inman especially is a very interesting guy, but there was always this almost like this religious warfare against the proper method. People would argue back and forth in there, but the reality is they both, most customers build a solution that incorporates pieces of both in there. And something I usually say later, what I'll say now is educate yourself on all the different options, architecture wise, Kimball, Inman, and then pick out what's going to work best for a use case, which is usually not a standard architecture that you can just pull out of the book, but rather you'll take bits and pieces of each of the architectures and do it for your particular use case. And Kimball and Inman become part of that. When you look at the way to design the architecture and the way to design the relationships between all the tables, and do I do a star schema or not on that, it all depends on the size of the speed and the type of data you have. All right, good. Thanks for the question. Keep them coming. A data lake, to explain it at a very high level, it's schema on read, meaning I don't have to do anything to put data in a data lake. In a relational data warehouse, it's schema on write, which means I need to do a lot of work up front to copy data into there. I have to create a table and the field and the schema. I have to write the ETL to copy the data into there. And so all that upfront work takes time. With a data lake, it's a glorified file folder. I can take, just like I do on my laptop, I can take a file and copy it into a data lake with a copy and paste. And it's that easy in a data lake. So there's trade-offs to that, but I can get data in a data lake very quickly. I can also get any types of data. It could be video files in there. It could be IoT files or social media in there. So it's not just limited to relational data in there. It can handle anything in there. And the reasons why you want to use a data lake on there is because I can put data in there so quickly that people who have a good understanding of technology can run reports off that very quickly. I don't have to do all that work that requires from a relational data warehouse on there. So I can do it for one-time reports. I can do it to see if the data is even valuable before going to the effort of writing into a relational data warehouse on there. So that's a big, there's a lot of benefits of a data lake. I'm just going to talk about a few. The other one is, and this is probably the most popular reason, if I have a relational data warehouse and I don't have a data lake, and I want to do, what I usually have is a maintenance window. I knock people off at night. I copy the data into the relational data warehouse into staging tables. I then clean all the data. I use a lot of compute. I do all that. Hopefully everything goes fine and it finishes by the time people come out in the morning on that. what happens if I want to get rid of my maintenance window on there? That's where a data lake comes into play. I can copy that data from the source systems into a data lake, and I can clean it, and I can do all that heavy processing outside of the relational data warehouse. And I can have that relational data warehouse running 24/7, except for maybe a few minute window where I copy the data over after it's been cleaned. But a lot of the work, almost all the work, is done in that cleaning part. That could be done outside of the warehouse in there, so you can have it 24/7. Also, when I'm using the data lake, I'm not limited to the compute, one type of compute like you are with relational data warehouse. I'm locked into the compute that data warehouse has. In the data lake is just storage, so I can use any compute that can understand the data lake, which is pretty much anything. So I can use all sorts of compute. I can usually save money. I can have more powerful compute on there. If I want to spend more money, I can have a big, huge cluster cleaning the data. A big benefit that you wouldn't get with a relational data warehouse. Because data lake storage is extremely cheap, I can put data in there even if I'm not sure if I'm going to use it or not. So I can stockpile data on there, something that you would usually don't do in a relational data warehouse because you're limited on the storage and you can have performance problems if you're just copying all sorts of data in there. Again, I can keep all history of the data like I can in relational data warehouse, but even more so in the data lake because it's unlimited storage. And relational data warehouses, they generally have certain tiers that could be allow you to store a lot of data, but there's going to be some limit. Where in a data lake in the cloud, there is no limit. You can store as many petabytes of data as you want in there. So those are two quick things about relational data warehouses, reasons in a data lake. Now let's get into a modern data warehouse which uses both of those technologies on there. So at a high level, an MDW modern data warehouse, you go through these 4 stages, and these 4 stages apply to all the architectures: ingest, store, transform, model, and visualize. In an MDW, you're going to first store the data in a data lake, which can be used immediately in many cases, and this is traditionally was used by data scientists for machine learning. I just want the data, don't clean it, just put it in there, and I'm going to go train my models on there. You also would clean that data and keep that stored clean data in the data lake. Now this gets into data lake design, a subject outside of this. I'll talk about a little bit in a few minutes in there, but the data lake would take the raw data, the clean data, and then in an MDW, you can still have a presentation layer in the data lake, but traditionally that was still too difficult for end users to use it because it's in this file folder format, and they use tools that don't really understand that. So what traditionally had happened was the data from the data lake, some or all of it would be copied to a relational data warehouse where it would be modeled. It would be put in third normal form and then possibly in a star schema. It would be aggregated and made easy for the end user to then visualize that data and use reporting off of that because it was now in a familiar type of storage for them. And this combination of a data lake and a relational data warehouse at a high level, this is what each did. The biggest one was the data lake is staging and prepping, where the relational data warehouse was the serving layer and also used for security because a data lake, even to this day, doesn't have as near the security features that our RDW has, like row level and column level security on there. So instead of going through a huge rigmarole to try to limit who can see what in the data lake, it was just easier to copy it into relational data warehouse and use something like row level security on there. So each of these objects, stores, data lake and data tables had their own benefits, and you kind of use the best of both worlds on there. And so drilling down a little bit more, a modern data warehouse would look like this. There's the 5 steps. The data lake itself would be breaking out into raw, clean, and presentation layers. If you heard about the medallion architecture that was popularized by Databricks, you had bronze, silver, and gold on there. You can have anywhere from customers have had 2 layers to 8, 9 layers on there. That's all part of the data lake design, because not only do you have to understand the layers, but then the folder structure within those layers in there. That's a very long topic. Then you model the data, which means copy it to a relational data warehouse with a third normal form and possibly a star schema, and then you can visualize it. So in the end, IT is doing a lot of work, a lot of copies of the data, but the benefit is that you get that surface BI by offering it in a way that makes it really easy for end users to create those reports. And I'm going to go through Data Fabric, and then I'll take some. I see some more questions on there that I'll take. So a Data Fabric is, and this is my definition, which most of the things in here, a lot of other people agree on. Data Fabric is one that I see a lot of differences of opinions. So this is James Serra's Data Fabric. You may disagree with it, which is fine. I don't claim to have all the answers. Nobody's got the golden definition of everything in there, but at least going through all these gives you a level set. And whether, even if you disagree, at least we all got a starting point. And so a Data Fabric, think of it as an evolution of the modern data warehouse in there. It's adding a bunch of features and functionality to a modern data warehouse to make it support more data meaning larger data, different types of data, different frequency of data on there, as well as supporting things like, or having features like a master data management in there, using data virtualization, having the functionality to get data that's streamed in, which could be many records per second in there. You could also have advanced security on there. You could have a metadata catalog that tells you what's in your data warehouse environment in there. You could create APIs that could be used to call the data instead of just using connection strings. And you can even design it with building blocks in there. So somebody can come along and say, well, I can't use that Data Fabric. It's not useful to me, but you have an ingestion piece that's really useful. So can I use that? And I've been at companies that design the Data Fabric to allow other people in the company to use pieces of it. And that's what I mean by building blocks in there. So the bottom line is it's just going to support more types of data, size, speed, and the type in there. So diving into the high level of that, it has add-ons on here in purple where it uses those additional functionality on there. So the security, master data management, APIs, and metadata. And then diving into that a little bit more, you can see this has a few more enhancements than what we saw in the modern data warehouse on here. So the whole idea is building something that's going to last for a while because it can support all sorts of data sources. And you never have to say no to an end user who says, oh, what you built is great. Can you add this data? Can you add this data? If you build it correctly, you can say, sure, I can do all that no matter what size, speed, or type of the data is. All right, so I'm going to pause there. And I see I got some questions on here. Do we usually build dimensional modeling on top of third normal data warehouses on there? I would say it is very common, especially in the Microsoft world if you're using Power BI, which works a lot better on star schemas. So most customers will use a star schema. The decision point then is, where is that star schema? Sometimes customers will keep it in a data lake or in a relational data warehouse. Other times those will have third normal form and the star schema will be done in the Power BI in a semantic model. It'll pull in third normal form data and create the star schema and land it into that semantic model in there. But star schemas have a big benefit of defining all the relationships and minimize the complexity because you're denormalizing and you're reducing the number of tables. And so that's really a big help when it comes to self-service BI. All right. Harry said, I thought Inman created physical marts from an EDW where Kimball used a schema-based marts in a single. Yeah, that's kind of it. I said, but each of them have sort of changed their architectures and supported the others. I've seen Inman, in his book, he talked about having star schemas and data marts on that. So Inman had a large data warehouse that had everything, all the subjects, and then you create data marts from that are based on subjects on there. Now those data marts can be star schema, and that's where Inman sort of changed his approach. He used to say it should be thermal form, then he said they could be star schema, which Kimball didn't invent, but he popularized the star schema. Where Kimball said, don't have one large enterprise data warehouse, have a lot of data marts, and logically there'll be one large data warehouse on that. But he's said at times he believes it's perfectly fine if you want to have a relational data warehouse that has everything and then go to data marts and not just a logical representation of it on that. So in the end, learn about both of them and just choose what's best for your particular use case. Kimball books are still great and relevant. Even the Inman books are still great and relevant in there. And some people said my book is sort of a bit of an update to like the Kimball book on there that includes some of the newer concepts like data mesh. And I made my book technology agnostic. I don't even talk about technology in there. I just talk about the concept. So even though I work for Microsoft, I didn't talk about any of the Microsoft products in there. So I wanted to keep it that way because I wanted to have a longer shelf life also. Let's see, Harry both used. Do you see data lake systems standardized around Parquet and Lakehouse, Delta Iceberg? So I'll get into that in a little bit. Actually, the next data lakehouse, I'll talk about that. And in medallion architecture, yeah, Harry, you have a lot of good questions there. Yes, do you use schema enforcement and versioning as part of master data warehouse? I'm going to talk about that in a little bit too. I don't want to repeat myself. Question from Donald. Do you know if Microsoft wanted to call Microsoft Fabric Microsoft Data Fabric? I assume maybe copyright issues. One of the B-side of Microsoft is a great company. I love working for them. I have problems with marketing sometimes with the way they name things, the way they rename things on that. And I started at Microsoft on a product called Parallel Data Warehouse, which was named the Analytics Platform System, which then got migrated to the cloud to be called SQL Data Warehouse, which then got renamed or incorporated into Azure Synapse Analytics, which then got incorporated into Microsoft Fabric. So what's that, 5 name changes on that? Microsoft, the product Microsoft Fabric is not a data fabric. It is more about the next topic, data lakehouse on there. So they called it fabric because if you think of a fabric, it's weaving its way, and that's a great way to think of a data fabric. And Microsoft Fabric is the same idea, but the technologies, the architecture it uses is more focused on a data lakehouse approach, which, as I said, is next. Okay. Let me go ahead. There's a few more questions. I'll get to them and just keep popping them in there. These are great questions. If I don't get to all of them, just shoot me an email afterwards and I'll answer them. So data lakehouse, the third architecture. I like to give a little bit of a history lesson of how we got here. For those as old as me, you remember in the late 80s, we had a data warehouse that handled big data. At that time, big data was probably like a gigabyte. And you bought a software package like a Teradata, later an Atiza, that had everything in it. It had the relational data warehouse, it had the ETL, it had the reporting, and those work great. And still to this day, I see customers using Teradata on-prem. And everybody's eventually going to convert to the cloud, but they're still around. And in the late 2000s, the data lake came out. And you remember we had Cloudera, Hortonworks, MapR were the 3 big ones. And they came out with, hey, a data lake can solve all your problems. You don't need relational data warehouses anymore, and do everything in a data lake. And that failed miserably. And what happened was people said, well, we still want to use a data lake, but we're not going to use it for everything. Instead, we're going to focus it on what I talked about, the modern data warehouse. Let's use the data lake for transformations and not try to do everything with the data lake, and instead keep the enterprise data warehouse in there and use the best of both. That was your modern data warehouse. That was your data fabric. Around 2020, which was, well, 4 years ago now, popularized by Databricks, they came out with the data lakehouse, which if you take data lake and data warehouse and you combine them, it's data lakehouse. Cute name on there. And the idea of a data lakehouse was we don't need a relational data warehouse anymore. And you go, wait a minute, didn't you just say that failed? Well, what's different now? What's different now is Delta Lake. Delta Lake is what has the technology that has most customers now avoiding using a relational data warehouses anymore because of Delta Lake. And what Delta Lake is simply a storage layer on top of an existing data lake. It's not its own storage. So I can take a data lake and store data in there in the data lake format. As the example here is, if I'm using Spark, instead of writing something in Parquet, I can just say Delta, and that gives me all these additional functionality that can be used with the data lake if you're using the Delta Lake format in there. Things like SQL commands. A data lake has no idea what SQL commands are. You can't use them against them. However, a Delta Lake, you can. You can use insert, delete, update, merge statements on there. So now you're opening up a lot of possibilities with files because I can do those individual SQL updates in there. So the whole idea is making your data lake more relational data warehouse-like, so you can get away with not having a relational data warehouse on there. It supports ACID transactions for one table. It supports versioning of the data. It has one system that can handle not only batch but streaming on there. It can do things like schema enforcement and schema evolution on there. It has a lot of performance improvements on there, including solving the small files problem, which some of you may know of. So all these things make using a data lake as the sole object storage in there possible. And if I look at this at a high level, you can see this is just like the data fabric, except I removed the relational data warehouse in there. I still have a modeling component because I still want to make my data appear that it's sitting in a relational data warehouse to end users by not having a file folder format interface, but rather a object, a semantic model that points to those files, but the end users don't see that. They just see what looks like a relational database to them. And the tools all support that now. I mean, they can actually just be a view that points to a file or a bunch of files in there. And that view is the semantic model that end users see. So the use cases for a data lakehouse, they solve 6 problems. I don't have to, I can reliability. I don't have to keep the data lake and warehouse consistent because I only have one. I have problems with the modern data warehouse, with the relational data warehouse being older, even if it's just an hour older, it's still older. Data scientists generally prefer files. So they prefer a data lakehouse going against folder and files on there. Even though storage is cheap, I only have one copy of the data. So I'm probably saving 50% off on my storage on there. If I have 2 copies, more security risk. If I have both relational data warehouse and data lake, I have to hire people, either know both or multiple people who know those technologies. I get rid of that relational data warehouse. I just need somebody who understands the data lake and Delta Lake in there. So diving into what that looks like, you can see this is very much like the data fabric, with the exception of the relational serving layer, what I call it, is that semantic model, that view or a Power BI semantic model that points to those files in there, but is the interface of what people use to get access to the data. It is optional, I put in there, because you can bypass it. You could still go right to the data lake and pull out those data in Delta format in there. But most times, especially with product like Microsoft Fabric, you're going to have a relational serving layer, a semantic model on top of the data sitting in the data lake. But it's not a copy of the data. It's just a semantic layer. Now, there is a can of worms. Everything has trade-offs, and that's what I try to put in the book, and that's really why I created it. Was I got a little bit miffed that people came out with hey, we got this new thing called data mesh, and it solves all your problems, and there's no trade-offs to it. Well, there is trade-offs. So everything's got trade-offs. With a data lakehouse on there, I don't have a relational data warehouse. So what am I sacrificing on that? One could be speed. Even with Delta Lake having a performance enhancement, it'll never be as fast as a relational data warehouse, which has been around forever, which people on the call probably know about: massive parallel processing technologies, indexing, statistics, caching, query point optimization, materialized views. None of those things exist in Delta format. So that could be a problem. Now, it may not be a problem for a lot of people. They can say, look, I don't, so it takes a few extra seconds for to run a report. I don't care. Or there's workarounds. Like I can say, well, if I need millisecond response time, I'm just going to pull that data into Power BI, import it, and I get that millisecond response time. So there's a lot of workarounds for some of these concerns on here. Again, there's no role of security, column of security, and whatnot within a Delta Lake. So if that's going to be a problem, then the answer could be like, you don't have to go to put everything in a relational data warehouse. You could say, for a particular set of data, I'm going to put it in a relational data warehouse because I do need role security, or I do need the extra speed. But again, there are workarounds, and one of the workarounds in Power BI is Power BI. It has the ability to import it and use role of security. So I see a lot of customers getting by these problems by using Power BI, and most other reporting tools can have does have those features to get around some of these issues on there. It could be a problem with people being used to relational data warehouse. And the interesting thing is, with the benefit of a schema on write is you have a forced metadata layer. I can't put data in a relational data warehouse unless I have metadata. It's got to have the table and the schema and the fields on there. In a data lake, the metadata could be anywhere or not even exist. I could have metadata that's the first line in the CSV file. I could have it in a separate file, or I don't have it at all. So that could be a problem on that. So you have to be really diligent about making sure all these files have metadata when you're using a data lakehouse on there. I don't have that problem in a relational data warehouse because you have to have metadata on that. So something to think about in there. There's extra complexity with that. So that's kind of what I just said. It's got the complexity is having a separate file for that. The metadata is separate from the actual data itself on that. Another issue is concurrency. If you have dozens, if not or hundreds of people trying to hit the same file in a Delta Lake, that could be a performance issue. Now, I would say to a customer, why do you have thousands of people are hitting a file? All they're using a dashboard. Well, you should import the file into Power BI and use that dashboard instead. So there's that Power BI workaround again. There are things that Delta Lake does not have, may never have, things like it doesn't have the idea of views or referential integrity. So if things like that are a problem, like referential integrity, well, you have to do that in code up front instead of putting it in a relational data warehouse. So again, if that's a problem, maybe that specific set of data could be put into a relational data warehouse in there, or you find a workaround for it. This used to be a problem, not really anymore. Products have to support Delta Lake if you're going to use it. Pretty much all the Microsoft products do now, but it's always something to think about if you're going to use Delta Lake. Are the tools I'm using, reporting tools, ETL tools, do they support Delta format? And yeah, so that's the concerns to think about when you're using a data lakehouse. Most customers now, they look through this list and they go, not a problem. This one I don't care about. This one I'm going to use Power BI for. And over time, this list has shrunk. And with a product like a Microsoft Fabric now, almost all of this goes away. I would say 90% of the time with customers, none of this is a concern anymore on that because the technology has the workarounds or the ease of use that this is not a problem anymore. All right, so last subject will be data mesh. Let me see, Harry asked the question, when can you have metadata in a data lake? You can have metadata in a data lake by using things like Avro and catalog services. Okay, that's a comment, valid comment. Can you order a can of worms? Yep. For those on the call, no, I'm just kidding. I don't sell a can of worms. And Harry said data lakes often become data swamps. Very true. A way to try to prevent that is by using a data catalog tool like a Purview or Informatica and Calibra on that. And that's what we recommend to customers to keep track of everything that's landed into their data lake. And that's another long topic. Decision support systems. I remember those in the 80s. Thanks, Donald. Okay, so let's jump into a data mesh. So data mesh, this took me a couple of years to come up with a simplified concept of that. And I do this all in my book because Zamek Belgani created data mesh, but it was not new concepts. She just packed it up really nicely. Credit to her. It's got a lot of people talking about data, which is great, but it was overly complex. The way to think about it is everything I talked about was centralizing the data in those architectures, copying these operation data from OLTP in from various areas. We'll call them domains. They could be HR and finance, and putting into a central location that IT owns. IT takes that operational data and creates analytical data for it. Data mesh, different. Data mesh says don't copy the data to a central location. Instead, it's going to be decentralized. Each domain, HR, finance, are going to create their own analytical data. So instead of copying operational data to IT, they keep it in their domain and they create the analytical data, and then they make the data available to other domains or other consumers. And that's why you see these dotted lines on there. So the whole idea is you're pushing the building of these systems to the individual domains and not giving it to IT. Right? So that's it at a very high level. I wish she would just explain it this way in the beginning of her book, but she overcomplicated it. But this is the way to think about it, and this will make even more sense as I go along. Now, I also need to point out right here that data mesh is not its own architecture. I even hesitated calling it an architecture in my book because it's not mutually exclusive, meaning I could be using a data mesh with these other architectures. For example, domain A here could be creating analytical data using a data lakehouse. Domain B could be creating analytical data using a data fabric. So each of those domains could be using one of those three architectures in here. So data mesh, and that gets into my next slide. Think of data mesh as a concept. It's not a technology. It's a huge organizational and culture shift, which is why 99% of companies will never create a data mesh in there. It's too much of a change. People hate change. Just creating the domains within a company could have massive restructuring on there. But data mesh has got a lot of hype, and it's not a magic wand you can go buy on eBay on there. It's a lot of work. It's a lot more work than those other architectures solely relying on them. The data mesh is, think of it, well, it is 4 principles. And the way to think of it is at a high level is, and this is where I try to simplify the way she explained it, domain ownership simply means all the domains that you create, again, those domains could be HR and finance, they own the data. Instead of arguing, if I copy it into a central location, does IT own it or does the domain own it? This argument goes away. The domains own it, and those domains are closest to the data. So at least in theory, they should be the ones cleaning the data because they know it best. So they maintain ownership. They're also need to make data as a product. So they're going to hire their own teams to create the analytical data. They're going to have their own infrastructure, and they're going to write the code that allows other people to access that data easily. Maybe they create API calls for pulling out the data as well as the metadata to see what's in there on that. So they're going to do all this work, and they may follow some contract in order to standardize on the way everybody's going to access data. So it's treating data as a product is the second principle. So you may be thinking, wow, this is a lot of work for each of the domains on that. Can we make life easier for them? That's where principle 3 and 4 come into place. The idea with principle 3, self-service data infrastructure as a platform, is ideally I want to create some sort of script that each domain could run, and it's going to ask them what their domain name is. It's going to build out their whole architecture for them. It's going to create the storage and the compute and the ETL and the security. Now, there's nothing that does that. Nothing even comes close. But maybe you can create some scripts or build some system to get each domain quick started and not have to reinvent the wheel. And that's the whole idea of principle 3, is making life easier for each of those domains. Along the same lines is the federated computational governance. Again, she overcomplicated things. I think that she chose a name that I don't even understand what it means, but what it does mean is you want to create some global rules that all the domains are going to follow. It could be, this is how you clean data. I don't want to have one domain using US states with 2 digits and another one using the full name in there. We have to have these standards in there. I don't want one domain using a security that's completely different than another domain because we need to combine the data. So you have to have all this work done. Maybe it's just a best practices book that are given each domain to follow. Now, where there's confusion is people think of data mesh as everything's decentralized, but that's not true. Principle 1 and 2, yes, those are decentralized. Domain ownership and data as a product. Each of the domain can keep their own data, but 3 and 4 are centralized teams that come up with the infrastructure as a code and come up with the global rules. Now they can be made up of individuals from each of those domains, but there are a centralized team that are going to build out those 2 principles on there. So this is where people get a lot of confused. So the use cases for data mesh, it solves 4 challenges, at least tries to. One is that you have these 4 problems you have with a centralized solution. Lack of ownership, that problem goes away. It's owned by the domains. The quality is improved because the domains know the data better, so they mentioned before, they're going to clean it. The 2 biggest reasons, the biggest benefits for a data mesh are organizational and technical scaling. If each domain has their own IT team, the more domains you have, the more teams you're going to have, the more people you're going to have. It prevents IT from becoming the bottleneck. Because if I have one central team and all these domains are sending me data, IT is going to get overwhelmed. They're going to become a bottleneck. It could take them weeks or months to come up with incorporating the data in there. With a data mesh, each domain is doing their own thing, so I have organizational scaling on there. I scale out. Along the same lines, technical scaling. If I have a central IT team, they may not have the infrastructure that can support unlimited data. In a data mesh, each domain has their own infrastructure. The more domains, the more infrastructure you have. I scale out. Now, all that sounds great in theory, but it falls apart in a lot of cases. But that's the idea of a data mesh. That's why people really liked it. If I look at what this would, a data mesh would be, is I would have multiple domains. As a healthcare example, means I have patient, clinical, claims, and public health. 4 domains. Each domain then has products within them. And this is an example of the product. So you have to look at your company and create these domains along with each of the products. I've seen customers with hundreds of domains and hundreds of products. So right here is where it really gets in a problem with a lot of customers in there, is how are we going to design all this? And so there's a lot of concerns that I have with a data mesh that I talk about in my book. And I won't go through these now. And there's a lot of them I didn't even put in the book because I don't want to go crazy with it. But some of you who've been around a while, like me, can go like, well, we've talked about these problems before, decentralization and centralization. We've had these discussions with Kimball and Inman on there. And some of the things that come out, it could cost a lot of extra money. Now, each of these domains have to create their own IT team. And they're going to go like, well, those domains may go like, I've never done anything like this before, building analytical solutions on there. I don't want to do it. Or where am I going to get the money? Or why should I be doing this? And if your reply is you should do it for the greater good, they're going to be like, I can't even keep what I have going. Now you want me to do all this extra stuff in there. So that's a lot of pushback you get. It's also very time consuming for each of those domains to do that. So they may have been having all these plans to do all this other stuff. Now they got to be put on pause because they got to go and they got to be part of this data mesh in there. And then the problem is there's no standard definition of data mesh. I talked about those 4 principles. If I follow 3 of those principles, can I call it a data mesh? This is what I talk about in my book, The Minimum Viable Mesh. I don't have the answer for it, but it's a good topic of discussion. If I do 2 of the principles as a data mesh, I've seen companies that barely follow 2 of the principles and they say it's a data mesh. And I go, well, it's really not. It's more like a Lakehouse, but they want to call it a data mesh, right? Fine. So the bottom line is it's really hard to define a data mesh in there. So it's really hard to build something if nobody can agree what the definition is. And should you adopt the data mesh? This is what Zamek had in a page of her book in there, where you have to score a medium or high in all these categories to think about adopting a data mesh in here. And this is where 99% of companies fail, because they're going to say, look, we're not tech at core. We're not early adopters. We're not already domain oriented in our business in here. We don't have a lot of organizational complexity. So this is overkill, or we're not modern with a lot of the things we're doing in here. So this is where it's not that I don't see companies doing data mesh, apart from nobody built a pure data mesh in there. Nobody's going to follow all 4 principles to the full extent on there. But I do see companies building a data mesh, but there's always a lot of exceptions. Like, well, we're not going to have each domain with their own data lake. We're going to centralize a data lake on that. Or we're going to have a centralized compute that everybody's going to be shared. So there's all those exceptions, but then some of those exceptions are so drastic, I don't know if I would even call it data mesh anymore. But the bottom line is understand the data mesh, because even if you say, look, I'm not going to build a full data mesh, you may say, but that data as a product sounds really interesting. I think I may use that. And that's where I see a lot of companies say, we're going to build a data lakehouse, but we're going to make the data, we're going to treat it like a product to make it really easy for other people to get access to it. So we're doing some concepts of the data mesh, but we're not going to build a data mesh in there. And so what I wind up seeing is this is where customers who are going to build a data mesh or do something similar to it start by creating parts of the mesh with new data, supplementing what they already have centralized. And over time, they may pull some of that centralized stuff and create other meshes on that. But they never get to the point where they get rid of the centralized solution, because, as I mentioned before, all it takes is one domain to go, like, I'm not doing a mesh. If you want my data, take it, and you got to centralize it. You can't ignore their data on there. So what I see is a kind of a happy medium with some companies is they may have some domains that do have the skilled technical people to build an analytical solution, and they would make my life easier in IT, because I don't have to incorporate the data. Data mesh is out there, so I keep what I have going, and new data maybe becomes a mesh, or maybe a brave domain will say, well, we'll stop sending the data and create our own mesh. And so this is the way I see it progressing, and I think this is the way it'll be, where it'll be a combination of mostly centralized with some data mesh out there. All right, so the final slide is when to use each architecture. This is where I tell customers there's always exceptions to these architectures based on your size, the speed, and the data. So modern data warehouse still could be used, have both a data lake and a relational data warehouse if you have a small amount of data, and if you're just really used to a relational data warehouse, even to the point where I've seen some customers don't even bother with the data lake. Now they lose a lot of benefits, but they go, James, I got 10 gigabytes of data, in which case I'll like just use SQL database as your data warehouse, and that'll work fine, as long as you don't think you'll have a lot more data in the future. And that's where a lot of customers make the big mistake, like, oh, I'll just do something quick and easy. I won't use a data lake. I don't have a lot of data. And then a year later, they get a request for all this data, and they're like, uh-oh, I got to go back to the drawing board again. I see a lot of customers with data fabric, especially if it's a large migration. They wrote a bunch of stored procedures, which would have to be written if you get rid of your relational data warehouse and just have a data lakehouse. Even though data lakehouse technology with Delta Lake is pretty robust, it won't support stored procedures out of the box, because it doesn't support all of T-SQL. So you have to do a lot of rewriting. So I've said some customers got thousands of stored procedures, and it's like, well, yeah, let's just use a relational data warehouse. Maybe down the road we'll convert those, but for now we'll have a data fabric where we have a relational data warehouse in there. Most customers are going the data lakehouse route, and I just say use it until you can't. Maybe I run into a performance issue. I have this particular database that's got billions of rows, and I need to do a lot of ad hoc queries, and Delta is just not keeping up with it, which that is the one common example as well. Just copy that billion into a relational data warehouse, and that would be the one exception to your data lakehouse in there. And then lastly, the data mesh. The companies I see it at there are a couple dozen companies that are building data meshes or have. Within Microsoft, they do have the exceptions, but they built out what I would call a data mesh in there. They're usually banks because they're or financial companies because they're already domain oriented. A lot of them are in Europe for some reason, and they have major pain points where they're like, look, this is not working. This is not sustainable. IT is getting overwhelmed. We need to make a change, and we do have a long timeline. So let's go and build a data mesh on there. But the closing, most companies will use pieces of each architecture adapted to their specific use case. And that's why it's important to learn about all these architectures and then take the bits and pieces that'll work best for your particular use case. I do a lot of architect design sessions with customers. I don't think I've ever had the same architecture built. There's a lot of discovery. I ask them what they're doing, and I'm like, oh, okay, well, you're gonna have this one exception. And then especially when you get down to the tools on there, it could be very different depending on the tools they're using, and that could affect the architecture. And then you get into, hey, James, your architecture is great, but it's too costly. And okay, we're willing to sacrifice performance for cost. Okay, let's talk about changing the architecture to be less expensive at the risk of not being as performant as you like. All right, so I'm 3 minutes over. I think we had an hour. And there's some questions. So whatever you want to do, I can answer some of the questions or we can call it a day, whatever you like.
Well, if you want to go ahead and just try to tackle a couple of the questions, and we'll call it maybe a little after 7:40, if you want to do that.
Okay. Yeah. So Harry has a question. Oh, surprising. Harry's been great with these are really good questions, Harry's. What is the schema development process with lakehouses and data warehouses? Where the schema usually resides in a lakehouse is depending on the technology. If you look at Microsoft Fabric, you have the ability to create lakehouses that underneath the cover, and even warehouses that underneath the cover are storing the data in Delta format, but through the interface, you create what looks like a relational data warehouse, but is actually not. So the metadata in Fabric is stored in a environment where you create the tables and the fields on there. So that's where the metadata is. It's in Microsoft Fabric on that, pointing to files that are sitting in Delta format in there. Like Spark's got its own metadata or its own catalog that you can use. Databricks has got their own version of that. So it depends on the technology where the schema is in there. And so most of the products have a process, a tool that score that schema on that, but they got to get it from somewhere in there. So if it's not with the file itself, they can use a tool to create it and store it in their particular product. What is the current primary relational OLAP warehouse offering on Fabric? So Microsoft Fabric is the newest tool. It's an awesome tool. I have videos where I go through it, and so Fabric has, as I mentioned underneath the covers, the idea of a lakehouse and a warehouse on there. So again, they're stored in Delta format, but it looks to an end user like it's a relational data warehouse, but it's really not. And so yeah, let's see. Harry, again, for schema development, how do you approach going from business needs to a defined schema, which is basically JSON-based files? Well, I'm gonna pass on that one because that's a little more complicated, Harry. But send me an email, and I'm even happy to set up a call with you to go over, because you have some great questions, and I like taking questions also because I'm gonna probably come out with another edition of my book, and so a lot of these questions are not covered in my book, which gives me an idea to put them in my next version on there. Let's see. Spark is such an overkill for 90% of business data jobs on that. My reply to that is yes, if you're not a Spark developer. So with customers, the tools now have become so advanced, especially Microsoft Fabric. You can do everything visually. You can transform data. It's no code, low code in there. So I always tell customers, don't use Spark unless you have to. Now, some of them come to me and say, we love Spark. We want to do everything in Spark. Okay, Fabric supports Spark. So if you want to do transformation in Spark, go for it. But most customers would rather not go open a notebook and create code to do all the transformations on that. So go and do it with those no code, low code tools, until you can't, which means maybe I can't get the performance out of that I would need. I'm going to have a giant Spark cluster to do it. Or I've seen customers say, well, I got a library that I need to use to decrypt this data, and I have to use Spark on that. So, and this is my personal view, is I'd rather not go into Spark, because it's also difficult for maintenance, unless the customer has a lot of great Spark experts and they've already done things in Spark. Okay, then go for it. Another one from Harry. Gartner said data mesh will be obsolete before plateau and hype cycle. Yes, and I have that graph in the book. And Gartner's interesting. I don't always agree with what they say. I don't really agree with them in this. I think sometimes when I first learned about data mesh, I thought, oh, this is really cool. And then as I start thinking about it more, and I go, wait a minute, these are the same problems we had 20 years ago and 15 years ago, and they're just packaged up and nice and nightly. And then I started thinking about all those concerns, and I thought, am I the only one? So I reached out to other industry experts who've been around like I have, and said, is it just me, or is this data mesh seem like overly hyped? And they're like, it's overly hyped. Everybody agreed with me, and they agree with the book and the things I put in there. So I sometimes think about 20 years from now, we're gonna go data mesh. Remember that thing? That was crazy on that. But I think it'll live on, if not in its full glory with all those principles, but rather a subset of it will live on. So maybe it will be obsolete in the terminology in there, but some of those concepts are going to live on because they've been around with us so long on that. So I can see either way with it, but it's greatly overhyped, and it remains to be seen if we're even talking about it 5 years from now. And DBT, let's see. Data mesh is big in corporations, highly regulated area like banking. That's where I've seen it in banking and finance on that, especially if they have a lot of time, which banks generally do, to go and build things out. Someone made the comment, lots of shadow IT for data mesh. Yeah, that's what that is, shadow IT. So, and I think I'll end with this. This is where I saw the problem with Kimball Inman. So Kimball sit around and have data marts. So what you had was all these departments going and creating their own data marts. They'd have their own IT team. They'd have their own infrastructure. And it's like, hey, we build what we need and we can share it. And this very much like what they're talking about data mesh. And so that was popular. But then what happened was some CEO would come in and go, wait a minute, why do we have all these IT teams using their own infrastructure? That's way too costly. Instead, let's have a central IT. We'll reduce the headcount, have one team, one infrastructure, and save a lot of money. That's where I see the problem with data mesh coming up. We're repeating history again, where people are going to build out this data mesh and have all these IT teams, and somebody's like, look at all the money we're spending. This is ridiculous. Why does each domain have their own infrastructure? Let's centralize things like that. So we're going to repeat the whole cycle over again. And that's where I had that last slide I had, where I think if you do it right, you can just have a combination where you're not going crazy with all these domains, but you have just a few that are doing the work, that are already technically oriented, that maybe already have their own shadow IT team and have their own budget and all this and own infrastructure already. So you can take advantage of that without going full data mesh. All right. So
Perfect.
Hopefully you got something out of this. I'll make this deck available, or you can email me. Let me pop up my email on here. If you want a copy of the deck, you can ask for it that way. There it is. And any follow-up questions, especially I know, Harry, you'll have some. Let's schedule a time to chat. Happy to do so. I love talking about this. I can talk about it all day. You can see I have been. My voice is starting to crack. But
Yeah.
this is my passion. So happy to have further conversations with anyone on the call.
One other thing real quick. I ran across a podcast you did with Making Data Matter. Do you mind if I share that link with the group?
Yeah, I appreciate you do. I have all the stuff I've done on my website, my blog, jamesfarrow.com. There's a presentation. So if any of this other stuff interests you, like I mentioned Microsoft Fabric, and there's recordings of that stuff. But again, feel free to email me if you have any questions. And if you want a copy of my book in PDF format, just send me an email and I'll reply with that book.
How do we get a signed copy?
I send me an email. I have a link that you can order it, where I'll just give it to you at my cost, and I'll sign it and deliver it. So just send me an email, and I have it on Etsy, where I give out signed copies.
Oh, nice.
Nice, thank you. Well, we got you definitely worked up at 11 o'clock at night. So you do eat and sleep and drink this.
This is
Well,
I'm
James,
a night owl. This is when I get my best thinking done, is late at night anyway. So
True. Most do. I call the ones that do that the geeks, because they pretty much are not owls. So
I'm a true geek.
Well,
I have been for a long time.
James, it was an honor. It was definitely a privilege to have you represent San Diego in its finest, especially this evening with our most that we've had on Meetup. So thank you. Hopefully we can get you out to San Diego and speak, because you'll be great too. But again,
I love San Diego.
you.
I used to live in Vegas, and we went to San Diego a lot on vacation, and so I'll get that beer when I'm down there.
All right, beer's on us, that's for sure. Thank you again, James.
Sounds good.
Yep.
Thank you, everyone.
All of you,
Thanks,
thank you
guys.
for joining us, and hopefully
Okay.
we'll see you all
Thank you.
soon. Thank you.
Thank you.
Bye.
Yay! Good.
That was an awesome one, guys.
It was really good.
Yeah, that was good.